Scientists have just made one of the most precise measurements yet of how fast the universe is expanding, and instead of solving a long-standing mystery, the results have made it even harder to explain. At the center of this puzzle is something known as the Hubble tension, a growing disagreement between two ways of measuring the expansion of the universe. One method looks at the nearby universe, tracking distances between stars and galaxies to calculate how quickly space is stretching. The other looks deep into the past, using signals from the early universe to predict how fast expansion should be today. In theory, both approaches should give the same answer, but they don't. Measurements of the nearby universe consistently show a faster expansion rate, around 73 kilometers per second per megaparsec. Meanwhile, calculations based on the early universe suggest a slower rate, closer to 67. That gap may seem small, but in cosmology, it's a major problem. Now, a large international collaboration has combined multiple independent techniques into a single, highly refined system to improve accuracy. This effort, known as the H0 Distance Network Collaboration, has produced a result with less than 1% uncertainty. It is one of the most precise measurements ever achieved. And the conclusion is clear: the faster expansion rate holds up. By linking different methods, including variable stars, supernova explosions, and galaxy observations, researchers were able to cross-check their findings. Even when individual techniques were removed, the overall result remained consistent. This strongly suggests the discrepancy is not due to simple measurement errors. So what could be causing it? One possibility is that our current understanding of the universe, often referred to as the standard cosmological model, is incomplete. The mismatch could point to unknown physics, such as new properties of dark energy, undiscovered particles, or even changes in how gravity behaves on cosmic scales. In other words, the universe may not be following the rules we thought it did. The findings also rely on data from major observatories, including NSF NORLAB, combining both ground-based and space-based observations. Until then, one thing is clear: the universe is expanding faster than expected, and it may be forcing us to rethink the fundamental laws that describe reality itself.
Scientists using advanced computer models, including simulations run on high-performance NASA systems, have made a long-term prediction about the future of life on Earth. And while the timeline stretches unimaginably far into the future, the implications are still striking. The research is based on how the Sun will evolve over time. As our star slowly ages, it will grow hotter and brighter, gradually changing Earth's atmosphere and climate in ways that will eventually make the planet uninhabitable. Over vast timescales, rising solar energy is expected to reduce oxygen levels in the atmosphere. As that happens, conditions on Earth will become increasingly hostile to complex life. Eventually, even microorganisms would struggle to survive. According to the study, often referred to as the future lifespan of Earth's oxygenated atmosphere, Earth's biosphere is tightly linked to the long-term evolution of the Sun. As the Sun continues its natural life cycle, it will slowly push the planet beyond the boundaries that currently support life. Earlier estimates suggested that Earth could remain habitable for around 2 billion years. However, updated models indicate that this window may be significantly shorter, potentially cutting that time frame in half. In the extreme long-term projection, Earth could eventually lose its oceans entirely, with surface temperatures rising far beyond anything life as we know it can tolerate. The atmosphere itself would thin, removing the essential ingredients needed for survival. One of the researchers behind the study, Kazumi Ozaki, explained that the planet's future is closely tied to the Sun's steady increase in brightness. As solar output rises, Earth's environment will gradually shift away from conditions that can sustain oxygen-rich life. However, scientists emphasize that these outcomes are not immediate concerns. The most extreme scenarios lie billions of years in the future, far beyond any human civilization timeline. Still, the study highlights a fundamental truth about planetary systems. No world remains habitable forever. Earth's ability to support life is temporary on cosmic timescales. While modern discussions often focus on climate change and environmental pressure in the present, this research places those challenges into a much larger context, showing how delicate and time-limited planetary habitability truly is. In the end, the prediction is not a near-term warning, but a reminder of Earth's long and evolving story in a changing universe. Earth's journey continues, and our understanding of its destiny grows deeper with every simulation. I'm your host, signing off. Astronomers may have just taken a major step toward uncovering one of the universe's oldest mysteries, the very first stars ever formed. For decades, these so-called population 3 stars existed only in theory. Scientists believed they were the first sources of light after the Big Bang, but there had never been direct evidence to prove they actually existed. Now, new observations from the James Webb Space Telescope are changing that. Researchers studying one of the earliest known galaxies, GNZ11, have detected unusual signals coming from a small nearby companion object. This region appears to have formed just a few 100 million years after the universe began, making it one of the oldest environments ever studied. What makes this discovery so important is the type of light detected. Scientists found a very specific signature linked to highly energized helium, something that requires extremely hot and powerful stars to produce. At the same time, they found no evidence of heavier elements like carbon or oxygen. That exact combination of elements is absolutely critical to this discovery. Modern stars contain a mix of elements created over billions of years, but the first stars would have formed from only hydrogen and helium, the simplest elements created after the Big Bang. The absence of heavier elements strongly suggests these could be remnants of that first generation. Further analysis confirmed not just helium but also hydrogen emissions from the same region. By studying the ratio between them, researchers believe these early stars were likely massive, possibly between 10 to 100 times the mass of our Sun, and burned extremely hot and fast. These stars would have lived short, intense lives before exploding in powerful supernovae, spreading the first heavy elements across the universe. In many ways, they laid the foundation for everything that came after: galaxies, planets, and eventually life itself. While more observations are still needed to confirm the findings, scientists say this is some of the strongest evidence yet that the universe's first stars were real, and that we may finally be able to study them, not just imagine them. If confirmed, this discovery could open a new window into the earliest chapter of cosmic history, helping us understand how the universe evolved from darkness into the complex structure we see today.
Deep inside Saudi Arabia's desert, scientists have uncovered a vast underground lava tube system that is reshaping what we know about early human life in the region. The site, known as Jirsan, sits roughly 125 kilometers north of Medina and stretches through a network of dark volcanic tunnels that have remained largely untouched for thousands of years. What researchers found inside is not just geological history, but a preserved record of human activity spanning multiple eras. Evidence from stone tools, animal remains, and ancient rock art suggests that this cave system was repeatedly used by human groups from the Neolithic period through the Bronze Age. Unlike surface sites, which are often destroyed by wind, heat, and erosion, these underground chambers acted as natural preservation zones, locking away traces of the past. Scientists believe Jirsan was more than a temporary shelter. It likely served as a long-term stop along ancient herding and migration routes, used over and over again across nearly 7,000 years. Inside the cave, researchers documented carvings and depictions of livestock, including cattle, sheep, goats, and dogs, offering a rare glimpse into the daily lives of early pastoral communities. Animal remains found at the site reinforce this picture of a mobile, livestock-based society that moved across the desert in search of grazing land and water. Chemical analysis of these remains adds another layer to the story. Isotope data shows that livestock primarily fed on wild desert grasses and shrubs, matching the natural environment of the time. This suggests herding practices were closely tied to seasonal landscapes and survival patterns in a harsh climate. Even more intriguing is evidence of change in human diet over time. While animal protein remained important, researchers found increasing signs of plant consumption, particularly C3 vegetation. This shift may reflect the early development of oasis-based farming, marking a gradual transition from pure nomadic herding toward more settled agricultural life. Experts say this discovery is significant not just for what it reveals about one site, but for what it suggests about the wider region. Lava tube caves across Arabia may hold an entire hidden archive of human history that has never been properly studied. According to researchers, this is one of the first times such underground volcanic systems in Saudi Arabia have been systematically analyzed, opening a new frontier in archaeology. What was once seen as empty desert is now revealing a deeply connected landscape of movement, survival, and adaptation, preserved quietly beneath the surface for thousands of years. Scientists have uncovered a groundbreaking fossil discovery in South Africa that is reshaping what we know about the early ancestors of mammals. The fossil belongs to Lystrosaurus, an ancient relative of mammals that lived 250 million years ago during the Great Dying Mass Extinction. Researchers have identified a preserved embryo inside what appears to be an ancient egg, settling a decades-long debate about how they reproduced. Using advanced high-resolution scans, scientists found that the embryo's jaw had not fully fused, a key feature of modern egg layers. This suggests the eggs were soft-shelled, likely providing better protection and more yolk to help hatchlings survive in harsh environments. This survival strategy, based on rapid development and independence, may explain why Lystrosaurus thrived while most other life disappeared. This discovery offers new clues about how modern mammal reproductive systems evolved and how life adapts during global crises. A tiny fossil with a massive story. Stay curious as we continue to unlock the secrets of our past.
A quiet walk through an English forest has led to an unexpected archaeological breakthrough that is reshaping how historians understand Britain's Bronze Age landscape. What began as a single stone standing in Farley Wood, Derbyshire, has now been revealed as part of a much larger ritual complex dating back around 3,700 years. For years, the Farley Moor standing stone was treated as an isolated feature. It stood alone in the forest, known to locals but largely ignored by researchers. There was no clear indication that it was connected to anything larger. That changed when a 24-year-old archaeology student, George Bird, began studying the site more closely. Having visited multiple prehistoric stone locations across the region, he suspected that this lone monolith might be part of a wider pattern hidden beneath the forest floor. He documented his findings and submitted them to Forestry England, encouraging a formal investigation. That tip set off a chain of events that brought together archaeologists, researchers, and the television program Time Team for a full excavation of the area. Once work began, the site quickly revealed its secrets. Beneath layers of soil and vegetation, researchers uncovered evidence of a structured ceremonial landscape. Additional stones were identified in positions that suggest they once formed an oval arrangement measuring roughly 82 by 75 feet. At the center of the complex, archaeologists discovered a stone platform built directly above a natural spring. This detail is especially significant as water sources were often associated with ritual and symbolic activity during the Bronze Age. The arrangement of stones combined with the platform and spring strongly indicates that the site was used for ceremonial or spiritual practices over an extended period. Carbon dating places the site around 1700 BC, confirming its origins in the Middle Bronze Age. Evidence also suggests that parts of the structure may predate the standing stone itself, implying that the location was reused and reshaped over generations. Experts say this discovery is part of a much wider pattern across Britain. While famous sites like Stonehenge are well known, many smaller ritual sites remain hidden. Many smaller and less visible ritual sites remain hidden in forests and rural landscapes. Archaeologists now believe that wooded regions may still contain monuments. They remain preserved simply because they have never been fully explored. According to researchers, the Farley Moor discovery highlights the role of modern observation. Local knowledge can play a crucial role in uncovering lost history. What was once thought to be just a solitary stone has now been reclassified. It is now part of a complex ceremonial site and a reminder that significant chapters of human history may still be lying hidden in plain sight.
A new concept in space exploration is pushing the limits of imagination and raising serious questions about the future of human civilization. It is called Chrysalis, a proposed generation ship designed not for short missions, but for life across centuries. This theoretical spacecraft would stretch 36 miles across, carrying 1,000 people on a journey lasting up to 250 years. Unlike conventional craft, Chrysalis is a self-contained world, one that begins its mission with no expectation of ever coming back. At its core, the ship would rotate to generate artificial gravity, allowing humans to walk and live without the damage caused by weightlessness. This is not optional. In deep space, zero gravity leads to severe health risks like muscle loss and bone deterioration. Inside, Chrysalis is envisioned as more than a machine. It is a fully functioning closed-loop ecosystem. Agricultural zones would grow food and produce oxygen, while biological waste is recycled back into nutrients. Everything must be balanced. Any failure in food or air recycling could threaten the entire population's survival. To prevent confinement fatigue, the interior design prioritizes psychological well-being with open, naturalistic layouts. Radiation protection is critical. Large water reservoirs surround the ship, acting as both life support and cosmic shielding. Because of its scale, Chrysalis cannot be launched from Earth. Instead, it must be assembled in space. Components could be launched from Earth or sourced from the Moon and asteroids to reduce the burden of Earth's gravity. Once completed, advanced nuclear thermal engines would push the ship into the deep space efficiency it needs for the long haul. But the most complex challenge is human continuity. Entire generations will be born, live, and die aboard the ship. Society must evolve in isolation, maintaining knowledge and governance without any contact with Earth. Chrysalis asks a profound question. If Earth is no longer our only home, can we carry civilization into the stars? NASA's Perseverance rover has made a discovery on Mars that is quietly reshaping what scientists thought they knew about the planet's geology. At first glance, the tiny pebbles examined in Jezero crater look completely unremarkable. But under detailed analysis, they reveal something extraordinary: microscopic traces of corundum, the mineral that forms rubies and sapphires on Earth. This marks the first confirmed detection of corundum on Mars. The discovery was made using Perseverance's advanced laser instrument system, which can analyze rock composition from a distance. The rover identified the mineral signatures while studying exposed bedrock along the rim of Jezero crater, an ancient lake basin that has become a key target in the search for Mars' geological history. The strongest signal came from a rock target named Hampton River. Using dual laser techniques, the rover both vaporized a tiny portion of the surface and measured the light emitted from the material as it reacted. The resulting spectral pattern closely matched corundum samples studied in Earth laboratories. Scientists later confirmed similar readings in additional nearby rocks, including Coffee Cove and Smith's Harbor. The repeated detections suggest that this mineral is not an isolated anomaly, but may exist in multiple locations across the crater rim. The grains themselves are extremely small, less than a fraction of a millimeter, and appear as ordinary light-colored specks in rover images. Without advanced instruments, they would be almost impossible to identify. Researchers say the finding is significant because corundum typically forms under very specific geological conditions on Earth, usually in environments rich in aluminum and low in silica. Mars, however, does not appear to have the same tectonic activity. This raises an important question: how did it form? One leading explanation points to meteorite impacts. When large space rocks strike the surface, they generate extreme heat and pressure for brief moments, conditions strong enough to create minerals like corundum. It suggests Mars has experienced more complex and violent surface chemistry. The discovery adds another layer to the growing picture of Mars as a planet with a far more dynamic geological past than once believed.
A major milestone in space logistics has just been achieved, as SpaceX successfully launched a powerful new cargo mission to support astronauts in orbit. On April 11, 2026, a Falcon 9 rocket lifted off from Cape Canaveral Space Force Station, carrying the upgraded Cygnus XL spacecraft toward the International Space Station. The mission delivered more than 5 tons of critical supplies, marking one of the most capable resupply efforts to date. This version of the cargo spacecraft represents a significant upgrade. Cygnus XL is designed to carry larger payloads than previous models, allowing more scientific equipment, technology, and essential resources to reach astronauts in a single trip. That increase in capacity could play a key role in expanding research capabilities aboard the station. The spacecraft has also been given a meaningful name, the SS Stephen R. Nagel, honoring Stephen R. Nagel, a veteran astronaut who flew multiple space shuttle missions and contributed extensively to human spaceflight. The naming reflects a tradition of recognizing individuals who helped shape space exploration. Once docked, the spacecraft is expected to remain attached to the station for several months. During that time, it will not only supply astronauts with food, tools, and research materials, but also assist in waste removal and ongoing operational support. This mission highlights how modern space operations are becoming more efficient and capable. With increased payload capacity and improved mission design, spacecraft like Cygnus XL are helping ensure that long-term human presence in orbit remains sustainable. As space agencies and private companies continue to collaborate, missions like this are setting the stage for even more ambitious exploration in the years ahead. Apple is moving closer to entering the smart glasses market, with new reports suggesting the company is actively testing multiple design concepts ahead of a potential launch. According to industry sources, Apple is currently experimenting with 4 different frame styles. These include both rectangular and rounded designs, ranging from larger frames to slimmer, more subtle options. The company is also exploring a variety of color choices, signaling a focus on both technology and fashion appeal. Unlike earlier ambitious plans that aimed for full augmented reality, Apple appears to take a more practical approach. Instead of advanced visual displays, the device is expected to focus on everyday functionality. Features may include capturing photos and videos, handling phone calls, playing audio, and Siri integration. This shift suggests Apple is prioritizing usability and mass adoption over cutting-edge complexity, especially after mixed reactions to its previous high-end headset efforts. Industry analysts see this as a strategic move. By simplifying the product, Apple could position its smart glasses as a lifestyle accessory rather than a niche tech device, directly competing with existing camera-enabled glasses already on the market. While a release is not expected until around 2027, a preview could come as early as later this year. If successful, Apple's entry could redefine wearable technology once again, blending convenience with innovation. For now, the project remains in development, but it signals Apple's continued push to shape the future of tech. It's a clear sign that personal tech is moving beyond the smartphone and into the very frames we wear.
Many people have had that unsettling moment. You talk about something with friends, and shortly after, it appears on your social media feed. It feels almost as if your phone is listening, but is that really what's happening? According to experts in the digital advertising industry, the answer is no. Smartphones are not secretly recording your conversations for ad targeting. The idea may seem believable, but the reality is far more complex and less dramatic. Processing constant audio from billions of devices around the world would require an enormous amount of power and infrastructure. Experts say this kind of large-scale, real-time surveillance simply isn't practical for advertising purposes. So why do ads feel so accurate? The answer lies in data, and lots of it. Every time you browse a website, use an app, or search for something online, you leave behind digital signals. Advertisers use this information to build a detailed profile of your interests, habits, and behavior. Over time, this data becomes so precise that it can feel like your thoughts are being tracked. There's also another factor: shared environments. If someone in your household searches for a product, you may start seeing ads for it too. That's because advertisers often group users based on shared networks, devices, or locations, making it difficult to distinguish between individuals in the same space. Researchers have even tested whether apps secretly record audio in the background. In large-scale studies analyzing thousands of mobile applications, there was no evidence found of hidden audio recording being used for advertising. However, that doesn't mean your data isn't being collected. Far from it. Companies track your online activity, app usage, location patterns, and more. This information is used to place you into categories, not by name, but by behavior. Interestingly, even these profiles aren't always accurate. Data reports can include incorrect assumptions about your lifestyle, preferences, or purchases. But despite the flaws, they are still effective enough to create highly targeted advertising experiences. If you want more control over your data, there are steps you can take. Choosing privacy-focused browsers, limiting app permissions, and supporting stronger data protection laws can all help reduce how much information is collected. In the end, your phone isn't secretly listening to your conversations, but it is watching your digital behavior very closely, and that alone can be powerful enough to feel almost the same.